want you to do, a lot of you are already open to it. That's great. Okay, I want you to open up to today's classwork, and I want you to work on this logic puzzle, see if you can get filled in. I do not want you talking about it with anybody, and if you get answers, you should be ready to explain how you know for sure. So please go ahead and get working on it. Taylor, let's go. Taylor. Oh, just you. Up to you if you want to use that little chart. You could use it. That's not required, but getting the answer is the most critical part. If you figure it out, which I think a lot of you will, just be ready to explain your choices. Well, I knew this because those kinds of things. And I'm saying it out loud. Ava, did they have it all solved already? Just curious. Okay. All right. Well. Just curious. Some people fly through this stuff. Some people hate it. You'll see. It's like life. If you do finish early, there's another one on the next page you can start looking at. Okay. If you don't, it's okay. I'll give you a little bit of time. Look at it early. Okay. Some people do. They really, really do. Okay, so what I want you to do now, and you gotta do this the right way. There's more than enough of you where you can do this the right way. If you think you have this done, I want you to find somebody else that also thinks they have it done so you can compare and see if you agree. If you don't have it done, find somebody else that's working on it and say, hey, okay, how are you using these things? You gotta reach out. You can move if you need to. You can move if you need to. Hey! We'll take it. We'll take it. Anything else? Charlene.
I thought you were going to talk about something.
All right, now.
I have all the things.
So let's talk about this kind of thinking and the kinds of things you're going to run into. One thing you need to get into your head early. very early. Some people live for this stuff. Some people, 100%, they can't stand it. Let's just take that inventory, okay? Who loves this kind of stuff? This is your kind of thinking. Put it up, be proud. It's all right, you're allowed. Okay? Who hates this and would rather do 100 factoring questions? Who's in between? You can take it or leave it. That's fine, okay? But it's okay. The good news is you can get better at it. Now, the chart is not required. Okay? In fact, you might have solved it without the chart at all. It's just there as a tool to kind of organize your thinking. Okay? Emmett and Austin's bikes are red and black, not necessarily in that order. The owner of the green bike finished in first. Xavier was fourth. Fun fact, I started with that, but you don't have to do that. Emmett didn't finish in second. The third place finisher, I should say, didn't ride a black bike. Okay? So how you choose to organize your thoughts is kind of up to you. How could you use this chart? I'm not going to fill the whole thing in. I started with this clue. Xavier was in fourth because I knew that. And then I placed him here, and then I knew that these ones were out. I kind of used it to just organize my thinking a little bit and then go forward from there. Okay? I'm going to show you the answer right now, and you can see where you landed. Then we can talk about how you would use the clues. Okay? So here comes the answer. Yes. Okay. Now again, for some of you, you'll zip through something like this in like 30 seconds. Others of you will take a couple of minutes. But let's talk about how you could use the clues, okay? So that's not so much a clue as like they give you a starting point. Xavier is 100% fourth. Emmett and Austin's bikes are red and black, not necessarily in that order. So how could I use that clue to at least do something? Layla. Yeah, Emmett and Austin, they're blue and black in some reason, but they're red and black in some reason, but they're definitely not what? Blue and green, so we can ditch those. Now you might say that's not that helpful. These things become more helpful later as you start knocking off other clues. The owner of the green bike finished in first. Anything I can do with that right now? Yeah, first and green are going to be tied up, so whoever was green here finished first, if you choose to organize it that way. I already talked about that one. Emmett didn't finish in second place. Okay, so if he didn't finish in second place, that's out. All of a sudden, my second place starts to open up a little bit. And the third place finisher didn't ride a black bike. So third place did not go through in black. So right now, you'd be like, that's not that helpful. Okay? How can I keep this thing rolling right now with any information, any clue? Okay, so
Because if Dominic couldn't have rode a black bike, so that means you can cross him off.
Dominic did not ride a black bike, so I can cross him off where?
Third.
Yeah. And I can also cross him off where? Third is what you're saying? Okay. What else? What else? Casey.
He had a blue bike because red and black are taken and green finished first.
Red and black are taken by these people. We don't even know how yet. We know that green finished first. So what did you say? We got it. Xavier had to do what? Xavier has a blue bike. Okay, and then all of a sudden things are starting to unlock. So we have Xavier taken care of. Okay, then we can piece the rest of the puzzle together. Okay, so that's kind of how you want to get this to go. You fill in the information you know, things start to unlock, and then you go. Now the chart is not required at all. Many of you can solve these kinds of problems without the chart, but it's an idea, a way to kind of organize your thinking a little bit and ultimately arrive at this particular order. Okay? This is a different kind of thinking. I don't know if anybody remembers what last week's was called. Anybody remember what that kind of reasoning was called? Inductive. This is not inductive. I'm not giving you a pattern. I'm giving you just the information. You have to piece it together. Okay? This is called deductive or, deduce clues or deductive reasoning. You're using known facts to reach a conclusion. You're not using a pattern, you're not using an observation, you're using known information to deduce or come up with your own conclusion, okay? Some of you looked at it, some of you did not, but with somebody around you or your table, why don't you read this question and see if you can figure this guy out. Same thing, if you solved it already, compare with somebody. And be ready to talk about how you know this. It's funny.
JS is back.
Okay. We'll find out. It's very subtle, but we'll talk about how to take this problem and make it not that bad immediately. How about a reader for this? I need you to emphasize the "it's funny" for us. Conlon, please.
Rose, Lily, and Daisy decided to buy flowers for their mom on Mother's Day. One of them bought roses, the other lilies, and the third one daisies. It's funny, said the girl to roses.
This is really good.
We bought roses, daisies, and lilies, but none of us the flowers matching our name. You're right, said Lily. What kind of flowers did each of the girls buy?
Okay. So, anybody have any advice about the first thing you could do in the chart? It's something you could do right away, Cole. What would you do?
Like you can cross off all the things on the diagonal so can match your names.
Yeah, 100%. Rose didn't buy roses, Lily didn't buy lilies, etc. Now you might think that doesn't help. Hey, you're like on your way. Now there's another subtle clue in there. See as a table, if you can know what it is, talk about it. If you already talked about it, talk about it again. There's another clue in there that's also a puzzle.
It's because the girl with roses and then Lily had to write
Alright, what's the clue? And it's not, it's funny, it kind of is, but still. Benji.
So Lily said you're right to the person who had the roses, so she can't have the.
I guess it kind of is, it's funny, but really it's that sentence, said the girl with roses. Okay? Meaning, when Lily says you're right, what does Lily, what do we know about Lily now? Lily does not, go ahead, you say it again. Have the roses. So if Lily doesn't have the roses, we're like almost done now. Who's got the roses? Daisy. What does Lily have? That's out right there. Good. So, question.
You could do it and not cross off the others. You could see where none of the boxes available will overlap. Like for lilies, if it doesn't overlap with anything else, then if it's just that one box that's open,
Yeah, I mean, there's not one way to go about doing it. The important thing is you're using the same information to kind of deduce those clues. Okay? But that kind of gives it away right there, that clue, no matter how you use it. Okay? So this kind of reasoning is called deductive reasoning. And as I mentioned like twice, some of you live for this stuff, some of you don't. Good news, as we copy the definition, even if you don't live for this stuff, you can get better at it. Some people find the logic stuff kind of intimidating. They view it as a referendum on their IQ. That's not the case. Okay, it's just a different kind of reasoning. But you can get better at it. Deductive reasoning, by definition, the process of reasoning logically from given statements. Given statements are also known as facts. This is not like me showing you a bunch of shapes in a pattern and saying find the next. That is inductive reasoning. You're very good at that. I've been watching you do that for well over a year now. I haven't watched you have to deduce a lot of stuff, usually just conversationally. If the given statements are true, deductive reasoning produces a true conclusion. Okay, so you should already be thinking, when I throw this word out there, conclusion, hopefully your mind is kind of thinking P's and Q's a little bit. Yes, absolutely. Okay, cool. So, I want to see what you do with the auto mechanic one. Go ahead and read the auto mechanic one together, and I think there's only 2 questions. And only give me a conclusion that you can actually say for sure.
Well, technically, it has no, well, like, there could be another way that it
Yeah, but yeah, he's right.
Okay. Let's see here. An auto mechanic knows that if a car has a dead battery, the car will not start. Has anybody ever been around with mom or dad when the battery's died? How's that go over? Okay? Yeah. Sometimes somebody has to jump the car or you get for AAA to come. The car will not start. A mechanic begins working on 2 cars and finds, so there's 2 cars. There's car number 1. Car number 1 won't start. We'll actually start with that one. What conclusion can you make? Grace? Is that what everybody wrote? Anybody write something different? Jack?
There's no way of knowing.
Okay, well, there's no way of knowing if it's a dead battery, is what you're saying. Anybody have anything else? I wrote something slightly different. Sorry.
There's like something wrong with the car.
Okay, there is, where'd it go? There's something wrong with the car. Which is pretty much where we were going with that with Jack. There's something's not right. Could it be a dead battery? Yeah, do we know that for sure? We do not, okay? He knows if a car has a dead battery, then the car will not start. But if you reverse it, we don't know if that's true. I heard somebody back there say reverse. It might have been you. Okay, but if you reverse it, if a car will not start, then the battery is dead. He didn't say he knew that. Okay, that's all we know. Something is wrong with the car. We don't know what it is, but something's wrong. Okay? Car number 2, this one I expect you to get. Car number 2 has a dead battery. Grace, you want redemption on this one? Car won't start. Okay? Very good. So the reversible nature of it means he can't necessarily draw that conclusion that you would expect. Just because the car won't start doesn't mean the battery is dead. But if the battery is dead, car's not starting. He knows that for sure. Okay? Cool. What you just saw is an example of the law of detachment. If a conditional is true and the hypothesis is given, then you can make the conclusion. Please write down the law of detachment. Well, that's already written for you, actually. You're going to write the symbolic form in a second. Okay? So let's go back. If a car has a dead battery, what is that? That's my P? Then the car will not start. That's my conclusion. So if that's a true conditional, then the law of detachment states the conditional is true and the hypothesis is given, then the conclusion is true. Symbolically, what this means, if P to Q is a true statement and P is given, then Q is true. You are detaching the conclusion and making it true. But what we just saw a minute ago was the first one they gave you was you were trying to use the law of detachment that way. We don't know that that's true. That's why we can't use the law of detachment. You can only use the law of detachment if the conditional is true and the hypothesis is given. Okay, so that's what it looks like. P to Q is true, P is given, therefore Q must be true individually on its own. Okay? The reason they tried to, I'll go back to it, the reason they tried to fool you there, the conditional was P to Q. Okay, this was you trying to do Q to P. Okay, and then now it's P to Q. Okay, cool. Questions about the law of detachment? The symbols I think are helpful. So P to Q is true, P is given, therefore Q itself is true, even if they didn't tell you it was true. Okay? Talk about the midpoint one together. Okay? Actually, you know what? How about just 2 at a time? Okay, or you want to try them all? Why don't you try them all? Okay, there's 5 of them. Read them and decide what conclusion can you make. If you can't make a conclusion, write no conclusion. Go ahead, read them carefully. Try all 5. What conclusion can you make? If you can't make one, say no conclusion. Not all of them can be concluded, by the way.
Like it could be like this, like it should and then
All five. All five. If you can't draw a conclusion, just say no conclusion. If you can't draw a conclusion. We also missed one of the givens from the auto mechanic. It's actually, I don't know what's involved in it.
The student will pass the course. Lucia got an A on her history final exam, so she will pass the course.
It never said English. No, it says student gets an A on any final exam. It's in general.
Another minute or two. We'll talk about those five. The last one's a little different.
figure the square, then its side length, then its sides have equal length. Figure A, B, C, D, its sides have equal
What if it's a regular pencil? Yeah, what if it's a regular pencil?
So you're
No, but it could be like a
Okay, finish up. Let's go. Probably last one.
So of course, large levels work.
The last one's a little different than this.
Oh, a square is rectangle.
And, okay, so let's look. So before we go through them, please look at the board. The first four are law of detachment. The last, there's five of them again, right? Yeah. The last one is different. Okay, but the first four is the law of detachment. Some of you I still don't think know what it is. If P implies Q is true, if they give you P, then you can conclude Q. That's what the law of detachment means. When you can't conclude Q, it either means this is not given or this is not true. Okay? So let's look at each of these, okay? And some of you need to make a couple changes. Some of you have the right idea, but you have to draw a stronger conclusion. So you will see what I mean. Okay? If M is the midpoint of a segment, then it divides the segment into two congruent segments. So M is the midpoint of a segment is P. It divides the segment into two congruent segments is Q. Okay? Question, let's start there. Is P implies Q, is that true? Give me a thumbs up if that is true, thumbs down if it's not. Okay, it is true. That is a definition. The midpoint of a segment divides into two congruent segments. M is the midpoint of AB. That's the given. That's given P. So can we use the law of detachment? We can, but some of you didn't draw the right conclusion. You need to specifically state this. AM, segment AM is congruent to segment MB. You can't just say it divides it into two congruent segments. That's not enough. So I think a lot of you need to make that change based on when I was walking around. Okay, this is your actual legit conclusion because they gave you points. Okay? Now, I know a lot of you walking around, a lot of you just wrote down the conclusion. You just wrote down it divides the segment into two congruent segments. That's okay, that's not the right conclusion. The right conclusion is if M is the midpoint of segment AB, AM is congruent to MB. Okay, questions about that first one? Some of you just need to make your conclusions more specific. Okay? The next one, if two angles are adjacent, then they share a common vertex. Angles 1 and 2 share a common vertex. Okay, Ryan, what did you say for this one?
The angles are next to each other.
The angles are next to each other. Okay, Ronan?
It's no conclusion because just because they have the same vertex, they could be like not next to each other.
Conditional's not true. If two angles are adjacent, then they share a common vertex. Not true. Not guaranteed. Therefore, no conclusion can be drawn. No conclusion can be drawn. If the conditional is not true, or if the original hypothesis is not given, then you cannot draw the conclusion. Okay? So those are examples of what? What is this an example of? Two angles that share a common vertex that are what? Say it. Just not adjacent. Not adjacent. Okay? They're also not vertical. But thanks for playing. The people that said nothing. The people that said nothing. Okay? The third one. If a student gets an A on the final exam, then the student will pass the course. We have to kind of assume it's true because we have no other information about their grading scheme. Felicia got an A on her history final exam. How many of you drew the conclusion that Felicia will pass history? Put them up right. We kind of have to assume. Now, if you really tank the rest of the year, I guess you might not pass, but we don't have any other information. Okay? Cool. Okay? And then you have this one, and then we'll talk about why the fifth one's different. Okay? If a figure is a square, then its sides have equal length. Figure ABCD has sides of equal length. Okay, Caleb, what did you say here?
Square.
Huh?
It's a square.
You said that the conclusion is that it's a square. Okay, Cora.
I said that there's no conclusion because it could be like a rhombus.
If a figure is a square, then it has sides of equal length. But what if it was a rhombus? It has sides of equal length, and therefore you can't conclude that. But more importantly, just because we're given that they have equal lengths, it doesn't mean we can go off and actually say that it's a square. Okay, so a rhombus disproves that. Okay, now the last one is different. The last one is actually not law of detachment. Okay, this is kind of things that go against each other. If a quadrilateral is a square, then it contains 4 right angles. So that's like P to Q. If a quadrilateral contains 4 right angles, then it's a rectangle. That's kind of a different statement. Okay? Can we draw any other kind of conclusion from this? Anybody want to tell me what they said for this one? Okay, Caleb.
The quadrilateral contains 4 right angles and it's a rectangle or square.
So you're saying quadrilateral with 4 right angles. Go ahead, say again.
Is a rectangle or a square?
We don't want the or in there at all. Have a conversation. What's your final conclusion for this one? Or's not strong enough conclusion.
Yeah.
Can't have or in there. Can't be this or that.
I guess you just said
Okay, what's my conclusion? Cole.
If a quadrilateral is a square, then it is a rectangle.
If a quadrilateral is a square, then it's a rectangle. So why is this one different? It's actually 3 statements involved. If a quadrilateral is a square, then it contains 4 right angles. So that's my P. Okay, that's my Q. I don't know if anybody noticed, this one starts with Q. So we need another name for this. R. So P implies Q, and Q implies R. Anybody? P implies R. That's your conclusion. Okay. I can actually pull these things apart a little bit like this. There's your statement. There's your conclusion. If a quadrilateral is a square, then it happens to also be a rectangle. Okay? This has a name. It's called the law of syllogism. Okay? This one's already written for you as well, but you want to pay careful attention. You use this in your life all the time. If 2 conditionals are true, and the conclusion of the first is the hypothesis of the second, then a true conditional can be formed of the hypothesis of the first and the conclusion of the second. Nobody's ever going to spit that out word for word. Nobody ever. Not you, not me. Look at the symbols. The symbols are better. Okay? If P leads to Q is true, and Q leads to R, which is true, then what conclusion can we draw? P leads to R. You use this all the time in your life. Okay? People try to use it in sports, it doesn't work. We beat that team, they beat this team, so we will then beat that team. It doesn't work like that because sports are a competition, there's too many variables. But in math, it is true. P to Q, Q to R, P directly to R. Okay? It's called the law of syllogism. Okay, there it is in symbols. Okay, another example. If it is July, then you are on summer vacation. That's true. If you're on summer vacation, then you work at a smoothie shop. So what is the conclusion that we can draw from there? If it's July, what's it say? Then you work at a smoothie shop. Okay? Law of syllogism. Okay, it's actually logic that you use in your daily life. The difference is we can use it in math. We can't use it in some of the other things in our life. We probably try. Okay? Why don't you try the same kind of thing? There are, I believe, 5 of them. Can you use the law of syllogism? If so, draw a conclusion. If you can't, tell me no conclusion. 5 of them. Go ahead, talk about them together. If it works, you have to write the conclusion, draw the conclusion. If it doesn't, you say no conclusion.
When they say divisible, it has to be whole numbers. You know what I'm saying? That's like how divisible is like you can do. It's actually a word.
Did the first one work out? It should have. What's your conclusion? If a number ends in 0, then what? Divisible by 5. Good. Keep going. Keep going. All 5 of them.
No, this doesn't work because
0 divides by 5. 0 divides by all numbers with the exception of 0 itself. How many times does 5 go into 0? 0.
Did you say if an animal, whatever it is, if an animal is more adult than it is more endangered?
How about the second one? If a number ends in 6, then it's divisible by 2. If a number ends in 4, then it's divisible by 2. Conclusion?
No,
Why not, Sawyer?
because it's Q, it's P implies Q, and then it's R implies Q again.
Yeah, totally different statements. To be the law of syllogism, it needs to be P implies Q, and then Q implies something. Well said. This is no words even. P to Q, this is like R to Q. That's not the way the law of syllogism works. Okay, good. Couple more. Look at that right there. Spitting image for you hockey people out there. Back-to-back Stanley Cup champs, I believe.
So I saw lives in Ghana. When Ghana was already said, Ghana then you in Africa.
longest river in the world?
Oh.
Let's look at the panther one. I tried to trick you on this one, but we'll find out. If an animal is a puma, I have no idea. Concolor, Corey? Did I not say that? I don't know. Then it's endangered. If an animal is a Florida panther, then its scientific name is this puma. It's just puma. Yeah, right there. Okay. Did anybody draw a conclusion from this? Anybody? Grace, what did you say? Shh. If an animal's a what? Good. So if an animal's a Florida panther, then it's endangered. I don't know if anybody noticed what I did on that one. I would have looked at the second one first, because the conclusion of that is the hypothesis of the first one. Okay, so good job. Okay? Are we good with the other two? Are we still working? Good? Yeah, give it another minute. That's cool. Okay. I also don't know if the last one is true or not. Is that like fact? Can you look it up for me? Is it true? Yeah. Is it? Oh, I don't know.
One of those radio facts I remember.
Yeah. Good luck. Verified? You can draw a conclusion from the Ghana one if you live in, how do you say that? Is that Accra? Anybody know? Do we know anything? You're supposed to know stuff. I don't study this stuff anymore. I'm too old. Accra? We'll call it Accra. Then you live in Ghana. If you live in Ghana, then you live in Africa. Aisa. Asa. I'm going to go with Asa. Lives in Accra, therefore you can conclude that she lives in Africa. Let's do the last one. If a river is more than 4,000 miles long, then it's longer than the Amazon. If a river is longer than the Amazon, then it is the longest river in the world. The Nile is 4,132 miles long. Conclusion? Good. The Nile is the longest river in the world, which is verified. Fact. Okay? So just be careful. Only use the law of syllogism if you can draw those conclusions, okay? I want you to read the last question together and work on it. It is sneaky. And if you get it, I need you to explain why you know what you know. Okay, read this one together, though. Talk about it with somebody if you want as well. Yeah, start by reading the question.
Students on team 6C at this time, please report to the cafeteria.
I'm funny, Patty. Look at that.
Students, please report to the
Wait, but he can't.
He doesn't know that they both have blue. We can't, it's something they look for. If you're in the maybe they just
Can't look back, so he doesn't know.
Got it. I think that counts. There's a mirror in front of her. Exactly. Yeah.
sometimes deep, right? Can they just kill each other? Color half the color. Yeah, look, the ring that goes past his eyes. It's definitely like even if it's like this, like
Oh, yeah.
You do ultimately need an answer, but you also need to have kind of a flow of your argument. And obviously you have a 50-50 shot, but I don't want that to be the case. What? No, it's not. Maybe tomorrow. Maybe tomorrow.
I've seen this. It's like 12 people.
The CEO, Jared Wallace, report to the office. ATO Derek Foley, please report to the office.
Deductive reasoning is where rather than give you a pattern, I give you facts. I didn't want to see that. Instead of me giving you a pattern and say like use it to predict, here's all the facts.
I think that how could it
What? They can see in front of them.
maybe like the sunlight shining down.
There's not a mirror. There's not a mirror. It's not a trick problem. What? I'm out actually. You guys are back. Yeah. You can see what's in front of you. You can see everything in front of you. Correct. Cal can't see anything, but claims to know. Which reminds me of a lot of you. No, that's not the solution either. If you think you have an answer, please let me know. I'd love to read your argument. I read one.
My answer was
I'll see if you can read my
It's more philosophical. That's how
I understand your argument.
No, he knows.
I'll bet you Spain doesn't have any facts.
No way in the world does that ever go.
That might be the most I've ever seen.
These are all the possibilities. Red,
We're gonna find out now. Okay, let's take a look. Yes, in very disappointing fashion, I was asked what is deductive reasoning or deduce. That's what we've been doing all class. Okay. All right. Let's read the problem. Alan, Ben, and Cal, ABC, are seated as shown with their eyes closed. Diane, D. Yeah. Places a hat on each of their heads from a box they know, which contains 3 red and 2 blue hats. They do know that. They do know that information. Okay, they open their eyes, they look forward. They can see everything that's in front of them. There is no mirror, there's no trick solution. Okay? Alan says, I need Alan. Who's Alan? Who's Alan? Okay, so you're Alan. Alan says,
I cannot deduce what color hat I'm wearing.
hearing that, Ben says, I need a pen. Need a Ben. Benji, you're Ben. G.
I cannot deduce what color hat I'm wearing either.
Cal then says, Cam, you're going to be Cal. Oh, he says it with a little bit more than that, but okay, we'll take it. How does Cal know the color of his hat? Now, first of all, here's what you start with, okay? And you can eliminate things right away, but some of you have good arguments, and some of you, your arguments are a little bit lacking. Okay, so with a deduction problem, you kind of need to toss out options right away. Okay, so the first thing that happens is what? Alan looks ahead and says, I cannot deduce what color hat I'm wearing. What do we now know just based off of that? Jazzy. No, raise your hand. That's fine. Okay, Layla. You either have to write, he sees a blue and a red, or what could you have also written down? Okay, Moxley, you wrote this first. He does not see a what?
He does not see both of them having blue.
Okay, so the first thing you have to write is either he does not see 2 blue hats, or he sees a blue and a red. Why can't it be that? Because if he did see 2 blue hats, what would he know immediately? I'm wearing red, okay? So that's kind of out right away. Blue is out of the picture. Okay, so I kind of wrote this. I wrote all of my combinations. Aren't those kind of all of our options? Okay, and then I decided, okay, that is out. Help. Okay, and that's kind of all you get from him. Okay, Ben says, I cannot deduce what color hat I'm wearing either. What does this clue help us? Okay, Elena.
So if he knows that he's not wearing both blue, and he sees that Cal is wearing blue, then he sees that Cal is wearing red, then he can't tell what he's wearing.
Okay, so go through that just one more time for everybody.
So if Alan knows if Alan doesn't knows that there's not two blue hats in front of him, then Ben sees that Cal is wearing a red hat. He doesn't know what color hat he's wearing.
Okay. So Alan already said, I don't know. So now Ben knows they can't both be blue. Okay. So what one can we cross off now? Does anybody know? What can we cross off from here? Okay. So Eric. Can you cross off R from here? Cece? You want to cross off BR? I was going to cross off RB. Okay, we know that that's the case. And then it doesn't really matter which one he's wearing, okay, behind him. Cal knows these are my only options. I must be wearing red, and we could go from there, okay? The first step is probably the one that you have to state. Once Alan makes his statement, you need to either say he needs to see one red and one blue, or he can't see two blue in front of him. Once you have that statement, it kind of goes a little bit from there. Okay, ultimately, once you get down to these options, what is Cal wearing no matter what? It's got to be red. It's got to be red. Okay, cool. Good times. Okay, that leads to one last one. There's no problem to do. I just want you to look at it. A cracker company isn't pleased when it finds out the results of a survey it has taken. According to the survey, although customers would rather have a cracker than nothing at all. Just looking. This is real, by the way. Those same customers would prefer peanuts to anything else. A junior employee at the company decides that this is his big chance for a promotion, okay, or he has a big change. He claims to his boss that what the survey really said was that customers prefer crackers to peanuts. What is his logic? Talk about what his logic is. This is his claim.
Peanuts or nothing. Oh wait.
Try to take apart his logic, and then we'll be good.
So nothing. So the rating is nothing. So for least degree is nothing. Crackers and peanuts. No, but he says that the cracker is greater than nothing.
So his final claim, customers prefer crackers to peanuts. This was his thinking. Crackers are better than nothing.
If there's no peanuts, then we want crab.
Nothing is better than peanuts. Therefore, crackers are better than peanuts, okay?
What?
It's not right, it's a joke. It's a joke, it's his take on nothing, okay? Good times. Do they still eat these? Nasty. I never liked those. I always thought they were good. Always thought they were good. Please start looking at this. I always thought those were good. That's whole take on nothing. Also, Sam, wonderful argument. I thought about having us recreate the hat question, but it would have been too tough. Well, I couldn't have done it without reviewing the answer. That's all. That's true. You can do the hat question on your own at home.